Yeah, hello everyone. Welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is the database design concepts, and the same chapter, that is chapter number 7, that is the database design and the ER model. That is what are the database designs and what are the ER model that is available in the database design. So that is chapter number 7, database design and the ER model. So we have discussed, we have finished with the chapter number 7. We have finished with the chapter number 6 also, that is your advanced SQL, that is how to use the SQL and what are the relational query, relational algebra that is used. And now I'm going to, we have also started the next chapter. We have also started the last chapter number 7, that is the database design and the ER model. So let's take a quick review what we have covered in the last class, then moves to the today's topic, that is the ER model, that is the entity relationship model, that is the most important topic. So we have started with part 2 in the last class, that is the part 2, that is the database design. So our main focus is on the design of the database, that is how to design the database, or what are the various flowcharts, what are the various, we can say, the tools, we can say the symbol that is used for the database design. So this says database systems are designed to manage the large bodies of information. So what are the database system that is designed to manage the large bodies of information? These large bodies of information do not exist in isolation. That is, they do not exist in isolation, but we have to design the database so that the database will be, we can say, the compared, or database will be used for the database, so that the information will be gathered from the database, or maybe some device or service for which the database plays only a supporting role. The first two chapters of this part focus on the design of the database schema. So we have discussed about the focus, or we have focused on the design of the database schemas, that is what are the database schema, what are the logical entities that is used in the database schemas. The ER model described in chapter number 7 is a high level data model, that is today's topic, that is the ER model, and this shows the basic objects like entities, relationship among these objects. And this is one of the, we can say, the first step in the database design concept, that is the ER model, that is the entity relationship model. Relational database design, the design of the relation schema was covered informally in the earlier chapter that we have discussed. So there is a normal form that is used, a design of a complete database application environment that meets the enterprise wing model in a various design form, that is the designing of the web-based interface to the applications. Now, we have started also with the chapter number 7, that is the database design in the ER model. So what are the database design, or how to design the database, what are the various issues that is used in the database design. So up to this point in the text, we have assumed a given database schema and studied how queries and updates are expressed. We now consider how to design a database schema in the first place. In this chapter, we focus on the entity relationship model, that is the ER model, that provides a means of identifying entities to be representing in the database, that is how to identify an entity, or how to identify what are the different entities that is available in the database, and how these entities are related with each other. Ultimately, the database design will be expressed in terms of the relational database design and an associated set of constraints. So what are the various relational design constraints, and what are the various, we can say, the associated constraint that is available in the database design. This is the ER model that is based on the relational schema or relation schema. So 7.1 is overview of the design process, that is what is the design process, what are the various steps that is involved in the design process. So the task of creating a database application is a complex one. So whenever we create the database application, that is a very complex task that involves the designing of the database schema, designs of the program that access and update the data, and the design of a security scheme to control access to the data. That is how to design the program that is used to access and update the data, how to design the security schemes to control access to data, what are the various needs of the user that plays an important role, and what are the various design issues that is available in the database schema. The design of a complete database application environment that meets the need of an enterprise big model requires attention to a broad set of issues. That is, there are broad set of issues that is available in the database design. These additional aspects of the expected use of the database influences a variety of design choices at the physical, logical, and view level. So there are different levels that is available, that is the physical level, logical level, and the view level that is used for the database design. Then what are the various design phases that is available in the database schema, or what are the various phases of the designs? So it is feasible for a database designer who understands the application requirement to decide directly on the relation that is to be created, their attribute and the constraints on the relation. That is how to create the relationship, what are the various attributes and what are the various constraints that is available on the tables. So there are various phases that is available in the database design. That is the initial phase is to simply gather the requirement of the user. So first phase of this one is how to gather the requirement of the users, or how to gather the requirement of the end user, that is what are the various end users and what's their requirement that is used in the database design. The next, the designer chooses a data model. So first of all, the information gathered from the user, that is the requirements of the user. Then next place is the designer choose a data model that is used by applying the concepts of the chosen data model, translate these requirements into a conceptual schema of the database. That is, what are the conceptual schema that is used in the database design. The schema that is developed as this conceptual design phase provides a detailed overview of the enterprise. That is, what are the various detailed view of the enterprise, what are the various schema that is available in the conceptual model. And ER model is the best option for applying the chosen data model that translates the requirement, what are the various requirement and how to provide these conceptual design phase in the entity relationship diagram. Then next is showing the, or next step is in the database or in the design phase is the specification of the function requirement. That is, what are the various requirement of the specification, that is a functional requirement of the user, that is what are the various requirements of the users. Example includes the modifying, updating, searching, retrieving and deleting the data. That is how to modify, how to update, how to search and how to retrieve the data and how to delete the data. That is available at the conceptual level or the conceptual design. Then the next step is the logical design phase. So one is the functional requirement of the phase, one is the logical design of the phase that is used in the database design. So in a logical design phase, the designer maps the high-level conceptual schema onto the implementation data model of the database design that makes the format, or that we can say that will be used for the implementation of the database designs. Then we have also discussed about the design alternatives, that is what are the various alternatives that is available for the design phase. So there are various alternatives that is used, that is the entities and the relationship between the entities. So there are multiple entities that is used and there are relationship that is used with the different entities. In designing a database schema, we must ensure that we avoid two major pitfalls. That is, whenever we use a database schema, we must be ensure, the main target is to ensure that we should avoid, or we avoid two major pitfalls. That is, two major limitations are avoided for a database design. Now, what are the two major pitfalls that is available? One is a redundancy. That is, the data cannot be repeated. Or if there is a bad data design or bad design of the database, that may repeat the information. So there is a redundancy that is available. So if we store the course identifier and the title of a course with each course offering, the title will be stored redundantly, that is multiple times at the same time. So there is also redundancy that is also available in the database design. I'm so sorry. The next pitfall is incompleteness. That is, the design of the database also ensure that there will not be a incomplete database that is used. That is, the incompleteness is not there in the database design. So a bad design may take certain aspects of the enterprise that is difficult or impossible to model. Suppose that in case 1 above, we only had the entities that is corresponding to the course offering without having an entity corresponding to the courses. So what are the various relationship that is used? That is a single relationship that is used with the various information. So these are the two pitfalls that is used. One is the, we can say, the incompleteness, one is the redundancy. So these two must be avoided to ensure that database design will be a complete database design. Avoiding bad design is not enough. There may be a large number of good designs from which we must choose. Now, next is the entity relationship model. That is, what is the ER model, how it is used in the database design. So next is the ER model or entity relationship model. So that is the today's topic. So let's start with the most important topic, that is the ER model. So this is the ER model or the entity relationship model was developed to facilitate database design by allowing the specification of an enterprise schema that represents the overall logical structure of a database. That is, what are the various specification of the enterprise schema, what are the various we can say the schema, what are the various tools, what are the various logical design that represents the overall logical structure of the database. That is, the logical structure means what are the internal structure, what are the capabilities that is used in the ER model that represents the overall logical structure of a database. The ER model is very useful in mapping the meaning and interaction of the real world enterprises. So whenever I want to update the information, I want to choose the information that is a real type world enterprises that is used in the mapping the meanings and interaction of the real world enterprises onto a conceptual schema. Because of this usefulness, many database design tools draw on concept from the ER model. So there are various concepts that is also available on the ER models. The ER data model employs three basic concepts. What are the three basic concepts? That is the entity sets, relationship sets, and the attributes. So these are the three sets that is available. These are the three basic concepts that is available. One is the entity set, one is the relationship set, and one is the attributes, which we study first. So ER model also we can say the ER model is used or associated with the diagrammatical representation of the ER model that we study in this chapter. So this ER model is nothing but the entity relationship model, that is what are the various entities that is available in the database design and what is the relationship between these entities. For example, teacher teaches student. So there is a relationship between the teacher and the student, that is a teaches. So this is the ER model that is used to develop the database design. Now first point is entity sets. So what are the various entity and what are the various sets, steps or sets that is available for the entity. So entity is a thing or object in the real world scenario that is differentiable from all other objects. For example, each person in a university is an entity. That is, every person that is available in a university is an entity. An entity has a set of properties and the values for some set of properties that uniquely identifying an entity. So whenever we use an entity that have a different properties, that have a different values, that uniquely identifying an entity. For example, a person may have a person ID property. That is, there are multiple attributes like features. Suppose I am used as an entity and I contain various features like my name, like my age, my marks, my roll number if I'm a student. If I'm a teacher, my name, my address, my salary, these are the various features. So features means the properties of a entity. For example, a person may have a person ID property which uniquely identifies that person. So if I want to identifying the person, that is identifying by using the person ID. Therefore, the value 677899011 for person ID would uniquely identifying one particular person in the university. Similarly, courses can be thought of as entities and the course ID uniquely identifies a course entity in the university. An entity may be concrete such as a person or a book, or it may be abstract such as a course offering or a flight reservation. So entity may be a concrete entity or entity may be an abstract entity. So entity set is a set of the entities. So whenever I combine various entities, that is known as the entity set that shares the same properties or the attributes. So there are multiple properties, there are multiple, we can say the feature that is available. So if I combine all the entities that have a same feature, same property that is available, and if I contain or if I put all the entities of the same feature in one container, in one set, that is known as the entity set. The set of all the peoples who are instructors at a given university, for example, can be defined as an entity set instructor. So whenever we combine multiple people, that is a various set of people that is used, that is given in a university, that is known as the entity set instructor. Similarly, the entity set student might represent the set of all students in the university. That is, what are the various students, what is the set of or group of various students in a university. In the process of modeling that is used, we often use the term entity set in the abstract without referring a particular set of the individual entities. We use the term extension of the entity set to refer to the actual collection of the entity belonging to the entity set. So in simple terms, when I combine multiple entities of the same group of the same properties, that makes the entity set. For example, if I combine the various instructors or the set of instructors in the university, that form the extension of the entity set instructor. Entity set do not need to be disjoint. So there is no entity set that is to be disjoint. For example, it is possible to define the entity set of all the peoples in a university. A person entity may be an instructor entity, a student entity, both or neither. Now, an entity is represented by a set of attributes. So the entity that is used, that is represented by a set of attributes that is used. Attributes are descriptive properties that is possessed by each member of an entity set. So attributes are nothing but the descriptive properties that is possessed or that is used by each member of an entity set. The designation of an attribute for an entity set expresses that the database stores similar information about different entities in the entity set. So the same information, same property that is of the different entities that is used, that is the entity set. In real life, there would be further attributes that such as street number, apartment name, state, postal code, country, but we omit them in an example. So every entity has a value for each of its attributes. For example, instructor entity may have the value 12121, that is for use for the ID, and the value WU for the name, and the value finance for the department name. So there are different entities like ID, name, and the value that is available, and the value 90,000 for the salary. So each entity, each we can say the group has a different values for each of its attributes. The ID attribute is used to identify instructors uniquely. So if I want to identify the instructor in a unique way, that is used to identify by the use of the ID attributes. Since there may be a more than one instructor that is used with the same name, that is used with the identity. A database therefore includes a collection of the entity sets, each of which contain any number of entities of the same type. So there are different entities, different sets that is available that contains the entities of the same type. And there are two entity sets that is available. So if there is a university example that is available with the two entity sets, one is the instructor, one is the student. So a database for a university may include a number of other entity sets. For example, in addition to keeping track of instructors and students, the university has the information about the courses which are represented by the entity set course with attribute course ID, department name, and the credit. So there are different entities that is available. There is a department name, there is a department set, there is a course ID that is available. In real setting, a university database may keep dozens of entity sets. So there are multiple entity sets that is also available in the database design. Now, what are the relationship sets that is available? So, a relationship, that is a relationship set. So, we have discussed about the entity sets, that is a group of the entities, that is the entity sets. Next is the relationship sets, that is the what are the various types of relationship, that is what are the various group of relationship, that is a similar relationship. So a relationship is nothing but an association that is among the various entities, among several entities. So if I combine various entities, or if I want to represent the relationship between various entities, that is represented by the relationship. So it's an association among the several entities. For example, we can define a relationship advisor that associates instructor Katz with student Shankar. This relationship specifies that Katz is an advisor or Katz is an advisor to the student Shankar. This is the entity set that associate what are the various instructor that is available, that is Katz, with the student Shankar. And this specifies that the Katz is an advisor to the student Shankar. So relationship means what type of relationship does the entities have. Now next is the next paragraph says about the relationship set. So first paragraph is only about the relationship. What is the relationship? Now relationship set means combination of the various relationship, that it is a set of relationship of the same type. So if I combine various relationship of the same time, that is a relationship set. Formally, it is a mathematical relation on the n is greater than 2. That is a various relationship that is available. Now this is the example that is taken the two entity set, that is the instructor and the student in figure 7.1. These are the two instructor 7.1 instructor and the student. These are the entity sets. We define the relationship set advisor to denote the association between the instructor and the student. So there is a relationship. So one is represented with one, that is the Crick is represented with Tanaka, and the cats is represented with the Shankar and the Zhang, and the Srivasan is represented with the Brown, Kim is represented with the or associated with the Ao. So this is the relationship set advisor. What are the various relationship? What are the various advisor that is used with the relationship? That is the implicit relation and not usually specified relation. However, they are useful when the meaning of a relationship needs clarification. So in this case, when the entity set of a relationship set are not distinct, that is the same entity set participate in the relation, then set more than one in the different roles. There are different roles, there are recursive function that is also used in the entity sets. A relationship may also have attributes known as a descriptive attributes. So attributes also have a multiple form, multiple data that is used, that is known as the descriptive attributes. So as an example, we also consider the entity set, that is a student in the section. This is the example of the date as an attribute of the advisor relationship set. This is a date that is used. There are multiple dates. So when on this date it is available. The relationship sets advisor and the department advisor provides example of a binary set that involves, or that is one that involves the two entity sets. Most of the relationships set in the database system are binary. That is, most of them are the binary relationship that is used. Occasionally, however, relationship set involves more than two entity sets. Note that a student can or could have a different instructors as guide for different projects, which cannot be captured by the binary relationship between the student and the instructor. The number of entity sets that participate in the relation is a degree of the relationship set. So what are the various entities or the number of entity sets that is available that participate in the relationship that or participate in the relationship set, that is known as the degree of the relationship set. So this is the degree, that is a what or how many entity set that is available in the relationship. A binary relationship is set is of degree 2 and the ternary is of 3. So if there are three relationships that have a degree 3, if there is a binary relationship that have a degree 2. So we have finished with the what are the relationship sets, what are the various entities that is available in the relationship sets. Now next is the attribute. What are the various attribute that is available in the relationship sets? Just give me 2 minutes. So the next topic is the attributes. Now there is an entity, there is a relationship. What are the relationship? That is a relationship between the different entities. Now each entity have a different characteristics, different feature that is available, that is known as the attributes. So for each attribute there is a set of the permitted values that is known as the domain or the value set of that attributes. So there are multiple attributes, there are multiple values that is available for the permitted set, for the permitted value that is available, that is known as the domain or value set of that attributes. Domain means a domain means a area or the value set, or we can say the group that contains the various values. The domain of attribute course ID that might be the set of all text strings of the certain length. Similarly, the domain of the attribute semester might be the string from the set, that is a fall, winter, spring, summer. So these are the various semester that is available with the various strings or various, we can say the set, that is a fall, winter, spring, summer. So these are the semester attributes, we can say the domain value of the attributes. Formally, an attribute of an entity set is a function that maps from the entity set into the domain. That is, the entity set from the or entity set is a function that maps from the entity set into the domain. That is, what are the various domain that is available in the entity set. Since an entity set may have several attributes, each entity can be described by a set of pairs. That is, every entity is defined by a set of pairs, that is, the attribute and the data value pairs, one pair for each attribute of the entity set. For example, if I talking about the instructor, that is the entity that have a different sets like ID 76766, name Crick, department name biology, salary 72,000, meaning that the entity describes a person named Crick whose instructor ID is 76766, who is a member of the biology department with a salary of the 72,000. We can see at this point that an integration of the abstract schema with the actual enterprise being model. So the attribute value that is given have a significant importance on the data stored that is used in the database. An attribute that is used in the ER model can be differentiated or can be characterized by the following attribute types. So these are the following attribute type that is available in the attribute or that is available in the ER model. Now, first attribute is simple and the composite attributes. That is, what are the simple attributes, what are the various composite attributes. So in our example, thus so far the attributes have been simple. That is, the attribute that is given been simple. That is, they are not divided into subparts. That is the attributes, that is a simple attribute that is not divided into multiple parts, and the composite attribute that can be divided into subparts, that is a composite attribute. For example, an attribute name could be structured as a composite attribute consisting of the first name, middle initial and the last name. That is a composite attributes mean the dividing the same attribute into the multiple parts. Now, using composite attribute in a design schema is a good choice if a user will wish to refer to an entire attribute on some occasions. Now, also note that the composite attribute may appear as a hierarchy. In the composite attribute address, its component attribute street can be divided into street number, street name, apartment number. These are the simple and the composite attributes. Simple means that cannot be broken into multiple parts, that is a simple attribute. Composite means that can be broken into multiple parts. Now, next is single valued and the multi-valued attributes. So the attributes that is given that have a single value that is known as a single valued attribute. For example, the student ID attribute for a specific student entity refers to only one student ID. Such attributes are said to be single valued attribute. That is, a single value is available, that is a single valued attributes. Now, next is a multi-valued attribute. That is, if there are multiple values that is associated with one another, that is a multi-valued attributes. Now, this is the composite attribute. There is a name that is divided into three parts: first name, middle initial, and the last name. Address is again divided into four parts, that is a street, city, state, postal code. Then component attributes means street is also divided into multiple parts, and that is a street number, street name, apartment name. So this is the composite attribute, instructor name and the address. So the instructor may have 0 or 1 or several phones number, and different instructor may have different values. That is a multi-valued. That is a the same phone number will be used for the multiple places. That is a multi-valued attribute. So the second part is single valued. There is a single value, multi-valued, more than one value is using at the same time. That is a multi-valued attribute. Now next is the derived attribute. So one is a simple, one is a single valued, one is a multi-valued, one is a composite. Now next is the derived attribute, that is derived from some other attributes. So the values for this type of attribute can be derived from the values of other related attributes or entities. For example, let's say that the instructor entity set have an attribute student advice, which represents how many student an instructor advises. We can derive the value for this attribute by counting the number of student entities that is associated with that instructor. So as an example, suppose that the instructor entity set has an attribute age that indicates the instructor's age. If the instructor entity set also has an attribute date of birth, we calculate the age from the date of birth and the current date. This is the scenario, that is if one entity set or if one attribute is dependent on the other attribute, that is known as the derived attribute. An attribute takes a null value when an entity does not have a value for it. That is a null value. The null value may indicate or may also indicate not applicable. That is, a value does not exist for an entity. That is a value that is not available for the entity. For example, one may have no middle name. That is, one may have no middle name that is available in the entity set. Null can also designate that an attribute value is unknown. An unknown value that is maybe either missing or not known, that is already available. For example, if the name value for a particular instructor is null, that is, the name value that is given is a null, we assume that the value is missing since every instructor must have the name. A null value for the apartment number attribute could mean that the address does not include the null value or department numbers. Now next is the constraint, that is, what are the various constraints that is available in the null values. So here enterprise schema may define certain constraint that is available to which the contents of a database must conform. So that is a constraint, that is they define certain constraints, certain rules that is available to which the contents of a database must conform. That is the ER enterprise schema. In this section we examine mapping cardinalities and participation constraints. Now what is a mapping cardinalities? That is a cardinality ratio that expresses the number of entities to which another entity may be associated via a relationship set. That is a mapping cardinalities. That is a ratio, that is a number of entities to which the another entity can be associated, that is known as the relationship set. So via a relationship set, that is known as the cardinality ratio. So when we talk about the cardinality ratio, that is the number of entities that which other entity can be associated via relationship set. Mapping cardinality are most important in describing binary relationship sets, although they can also contribute to the number of relationship sets that involve the more than one entity sets. In this section, we shall concentrate on only binary relationship sets. For binary relationships, we should have a entity set that is available, that is A and B. So the mapping cardinality that is available is 1 to 1, that is what are the various entities that is related with each other, that is a number of entities that is related with other entity, that is known as the mapping cardinality. Right. So what are the various relationship that is used for a binary relationship? So first is the 1 to 1, that is 1 to 1 means one entity is associated with another entity. So one entity in A is associated with at most one entity in the B, and the entity in B is associated at most one entity in the A. That is one is related to another, another related to another. Now one to many, that is one entity is related with the many entities or four entities that is available, that is a 1 to many. So this is 1 to 1, A1 is related to A1, B1, A2, B2, A3, B3. Now this is A1, B1 and the B2 both, A2, B3 and the B4 both, A3, 5. This is more than one entities, that is a 1 to many relationship. Now many to one, that is more than one entities of one set will be related to the single entity of the another set. So this is A1 and the A2 is related to the entity that is the B1. A3 is B3, A4 and A5 is related to the B3. Now this is again the, we can say the many to many, that is more than one entity is related to more than one content. This A1 and the A2 both related to the B1 and the B2, that is a many to many. So the appropriate mapping cardinality for a particular relationship set obviously depends on the real world scenario that the relationship set is modeling. So what are the various relationship set that is modeling that is used in the entity relationship model? Okay. So as an example, consider the advisor relationship set. If in a particular university a student can be advised by only one instructor and an instructor can advise several students, so the relationship set is the instructor to student is 1 to many. So the instructor approach or advise several students, more than one student. So this is a relationship that is a 1 to many. Now next is the participation constraint. That is what are the participation constraints? So the participation of an entity set E in a relationship set R is said to be total if every entity in E participates in at least one relationship in R. If only some entities in E participate in relationship in R, the participation of entity set E in relationship R is said to be partial. So one is a participation constraint that is available, one is a partial that is used, the entity set that is a partial entity. In figure 7.5b, the participation of both A and B in the relationship set are total. So the A and B relationship that is available is the total. For example, we expect every student entity to be related to at least one instructor through the advisor relationship. Therefore, the participation of a student in the relationship set advisor is total. In contrast, instructor needs not advise any student. Hence, it is possible that only some of the instructors are related to the student entity set through the advisor relationship, and the participation of instructor in the advisor relationship set is therefore partial. So there is a partial relationship, there is a partial term that is also available for the entity set. Now next term is the keys, that is what are the various keys that is available in the database design or the entity sets. So keys, or we can say that uniquely identify the term, that uniquely identify the various columns, that is known as the keys. So this is the way, or we must have a way to specify how entities within a given entity set are differentiated with each other. Conceptually, individual entities are distinct from a database perspective. However, the difference among them must be expressed in terms of their attribute, that is the keys. That is what is the difference that is available in the various keys that is available in terms of their attributes. Therefore, the values of the attribute values of entity must be such that they can uniquely identify the entity. So what are the values that is available? That uniquely identifying the value that is available in the database design. In other words, no two entities in an entity set are allowed to have the same exact value for all the attributes. So it is not allowed to use the same value that is available in the database design that is available in the database set. Now, keys also has to identify the relationship uniquely and therefore differentiate a relationship from each other. So keys are also used to uniquely identifying the relationship. So one is it is used to uniquely identify the columns. Again, it is also used to uniquely identifying the relationship, or we can say the relationship that is between the entities. The primary key of an entity set allows us to differentiate among the various entities of the set. Now let R be a relationship set involving entity set that is the E1, E2 and the En. Now let the primary key denote the set of attributes that forms the primary key E1. So this is the relationship that has no attribute that is associated. This is the primary key E1, then union, primary key E2, then union, then primary key En. So a relationship that is maintained, there are no attribute that is available with the relationship. So the relationship set R as an attribute A1, A2 till Am associated with it. The set of attribute that is available is the primary key E1, E2, En, and the A1 and the A2 is also combined. Now this is the example that is given. Now next is how to remove, or that is a topic that is removing the redundant attribute in the entity sets. That is how to remove the duplicate data, redundant data or attributes, or we can say the features that is available in the entity set. So when we design a database using ER model, so when we design the database that is available in the ER model that is available, we usually start by identifying those entity set that should be included. So first of all, we are identifying the entities that should be included. For example, in the university organization we have discussed so far, we have decided to include with the entity set as a student, instructor, etc. Once the entity sets are decided upon, we must choose the appropriate attribute. So first of all, the entity set will be chosen, that is the student and the instructor, for example. Then the appropriate attribute will be chosen, that is what are the various appropriate attribute that is available. These attributes are supposed to represent the various values that will be captured in the database. So what are the various values that is available in the database design? That is the attribute. Suppose a person have an attribute like name, age, roll number, or name, age, salary. That is the attribute that is given over there. Now we could also add the attributes like phone number, office number, home page that is available. The choice of what attributes to include is up to the designer. That is what are the various attributes that is included, that is depends on the designer. For a good understanding of the structure of an enterprise. So there is a structure of the enterprise that is available. There is a good understanding that is available for the database design. So once the entities and their corresponding attributes are chosen, so once the attribute and the corresponding, or once we can say the entity and their corresponding attributes are chosen, the relationship sets among the various entities are formed. So there is a relationship that is also formed between the various entities. These relationship set may result in a situation where attributes in the various entity set are redundant and needs to be removed from the original entity set. So to differentiate between the various entity set, the entity set includes the attributes like ID, name, department name, salary. With ID is a primary key. So there is ID that is available that becomes a primary key. Now there is another entity set, another entity that is available, that is a department, that includes the attribute department name, building, budget, with the department name forming the primary key. So in the instructor table there is a ID that is a primary key. In the department table there is a primary key that is a department name. Attribute department name appears in both the entity sets. Since it is a primary key for the entity set department, is it redundant in the entity set instructor. So department is also redundant in the primary key, or also duplicate in the entity set instructor. So this is the department name, this is the department name, this is the building, this is the budget. So department name is the duplicate data that is available. So removing the attribute department name from the instructor entity set may appear rather intuitive, since the relation instructor that will be used in the earlier chapter have a department name. Also, we have created a relationship schema from the ER model. The attribute department name gets added to the relation instructor, but only if the instructor has at most one associated department. So treating the connection between the instructors and the department uniformly as a relationship rather than as an attribute of the instructor. That makes the logical relation explicit and provides a assumption that the each instructor is associated with only one attribute. In a similar way, the student entity have a department entity that is associated with the student department. So there is no need to give the department name attribute in a student. This is the student department. As another example, consider the course offering that is available along the time slots of the offering. Every time slot is identified by the time slot ID. So simply how to remove that? By changing the name, by changing the, we can say, the identifying column that is available in the ER models. Now these are the various, we can say, good entity relationship design that does not contain the redundant data. So for example, we list the entity sets and their attributes with the primary key underlined. This is the classroom with the attribute. There is a building, there is a room number, there is a capacity. So the primary key is building and the room number. Now next is the department with the attributes, department name, building and the budget. So the what is the primary key? That is the department name. Now course with attributes, course ID, title, credits. Then instructors, ID, name, salary. Then section, course ID, section ID, semester, year. All are the primary keys, or all are the, we can say, the keys or the set of entities that is available, that is used as a primary key that uniquely identifies the column. Now the relationship set that is used in the design are listed below. There is the inst department that is relating the instructors, then student department that is relating the student with the department, then teaches, then takes, then course ID, then section ID, section class, section time slot, advisor and the prerequisite that is available. Now next is the ER diagram, that is what are the various ER diagram that is available. So as we saw briefly in section 1.3, ER diagram can express the overall logical structure of our database graphically. So whenever I want to represent the database structure graphically, that is represented by the ER diagrams. ER diagrams are simple and the clear. That is, ER diagrams that is available are very simple and the clear diagrams that qualities that may well account in large part of the widespread use of the ER model. Now what is the basic structure that is available? So ER diagram consists of the following major components. So what are the major components? So first of all, there is a diagram that is, these are the various connectors. So just do one thing. First of all, let's take a break only for 10 minutes because today I'm going to finish the class early because I have to go somewhere. So let's take a only 5 to 10 minutes break, not more than 10 minutes break, and then move to this topic, that is the ER diagram. That is how to represent with the ER diagram. Let's take a break right now. So come back from the break. Now let's start the session again. So next topic is ER diagram, that is the entity relationship diagram. So what are the ER diagram that is available in the entity relationship, or how to represent the various entities and the relationship in a diagrammatical form, that is the entity relationship diagram. So this is a ER diagram that expresses our logical structure of a database graphically. So if I want to represent the database in a graphical format, that is done by the ER diagrams. And ER diagrams are simple and the clear qualities that may be, or that may well account in large part of the, or for the widespread use of the ER model. So that is a ER model that is simple and the clear, and that may concern about the large part of the widespread that is used for the ER model. Now what is the basic structure of the ER model? So this consists of the following components. First of all, there is a rectangles that is divided into two parts that represents the entity sets. So there is a, we can say, the rectangle that is divided into two parts that is available, that represents the two sets that is available over here. This is a rectangle that represents the entity set. This is the instructor, and these are the various attributes of the instructors. Now next is the student. These are different attributes of the student. The first part, which is in this text box, is shaded blue, contains the name of the entity set. So this is the entity set. This is the entity set. The second part that contains the name of the attribute of the entity set. So these are the various entities that is available. One is the ID, one is the name, one is the salary. Now Next is the diamond that represents the relationship set. This is a diamond that represents the relationship set. So one is the instructor, one is the student, that are the various entities, and that is represented by the rectangle, and the relationship set is represented by the we can say the diamond, or we can say the diamond represents the relationship set. Then there is an undivided rectangle that represents the attributes of a relationship set, that are a primary key, that are underlined. This is the primary key of the instructor, this is the primary key of the student. Then lines that links entity set into the relationship set. So this is a line that represents or that link to the entity set to the relationship set. Then dash line that indicates attribute of relationship set to the relationship set. If there are more than one relationship, that is represented by the dotted line, and the line are simply used to represent or to connect the entity to the relationship set. Then this is a dash line that link the attribute of one relationship to the relationship sets. Then double lines that indicate the total participation of an entity in the relationship set. Then double diamond that represent identifying relationship set that is linked to weak entity sets. That is, if there are weak entity set, that will be represented by the double diamonds sign, double diamond symbol. So consider the ER model, ER diagram that is available in figure 7.7. This is the 7.7 that is available, which consists of two entity sets. There are two entity sets, one is the instructor and the student. That is related to a binary or through a binary relationship set, that is the advisor. This is the advisor that is used to combine the relationship between the instructor and the student. The attribute that is associated with the instructor are the ID, name, and the salary. So these are the IDs, name, and the salary. And the attribute that is associated with the student are the ID, name, and the total credit. And the attribute of is on the primary key are the underline. So these are the various topics, or these are the various scenarios that is used. This is the entity set, this is the instructor, entity set, entity set. These are the various attributes of the entity set, various attributes of the entity set. This is the relationship that is represented in the diamond shape. If a relationship set has some attribute that is associated with it, then we enclose the attribute in a rectangle and link the rectangle with the dashed line to a diamond that represents the relationship set. This is a relationship set. For example, in figure 7.8, we have the date descriptive attribute that is attached to the relationship set advisor. So specify the date on which an instructor becomes the advisor. So this is the instructor, this is the student. These are the various attributes. So sorry. And the advisor is, or the date is associated with the advisor to specify on which date the advisor comes. This is the instructor, this is the student. These are the various attributes: ID, name, total credit, ID, name, salary. This is another relationship: instructor, student, advisor, advisor. Now this is the one-to-one relationship. This is the one-to-many relationship. This is one-to-one. This is one-to-many, and this is many-to-many. Without any arrows, this is the many-to-many. With one arrow, that is a one-to-many. With one-to-one, both sides arrows are given. Now, next is the mapping cardinality. That is how to map the various cardinality that is available. So the relationship set advisor between the instructor and the student entity set may be one-to-one, one-to-many, or many-to-many, or many-to-one. So it's either one-to-one, either one-to-many, either many-to-one, or many-to-many. So to differentiate among these types, we draw either a rectangle, we draw either a directed line, that is the arrows, or an undirected line. So if the arrow is located, that is a directed line. If there is an undirected line, that is simply the line that is represent between the relationship set and the entity set in question. These are the various mapping cardinality. One is one-to-one, then one-to-many, many-to-one, and then many-to-many. And ER diagram also provides a way to indicate more complex constraint on a number of items or the number of times each entity participates in the relationship. So with each entity set that is participating in the relationship that is available, that is represented by the ER diagrams. Now next is a complex attribute, that is how the complex attributes are represented, or how to represent the complex attributes. So figure 7.1 shows how composite attributes can be represented in the ER notation, that is 7.11. This is 7.11, that is with the composite, multi-valued, and the derived attributes. So this is a composite attribute, that is a name, with a component name that is the first name, middle name, last name replaces the simple attribute that is the name of the instructor. As another example, suppose we were to add an address to the instructor entity set. The address can be defined as a composite address attribute address with the attribute street, city, name, zip code. So these are the various multi-valued attribute, derived attribute as well as the composite attribute. The attribute street is itself a composite attribute whose component attributes are street number, street name, apartment number. And figure 7.1 illustrates how the multi-valued phone number is denoted by the phone number and a derived attribute age that is depicted by the age. Right. So these are the various we can say that how to represent the complex attributes or what to do with the complex attributes. Now next is the roles. That is, what is a role? So we indicate the role in the ER diagram by labeling the line. So this is a role, that is a course ID, prerequisite ID that connects the diamond to the rectangle. So if I want to connect the rectangle with the diamond, that is connected by the course ID and the prerequisite ID. Now figure 7.12 shows the role indicator, course ID and the prerequisite ID between the course entity set and the prerequisite entity relationship set. Now next is the non-binary relationship sets that can be specified easily in an ER diagram. So it consists of three entity sets: instructor, student and the project, that is related to the entity set project guide. This is the project guide, this is the project that is represented with the help of the project guide. Now next is the weak entity set, that is how to do or what to do with the weak entity set. So a section unity or entity that is uniquely identified by a course identifier, semester, year and section identifier. Clearly the section entities are related to the course entities. Suppose we create a relationship set course between entity set, section and the course. Now observe that the information in the set course is redundant since the section already exists in the course ID. So one option to remove is to get the relationship between this one. Alternative way is to not to store the attribute course ID in the section entity. So these are the various attributes. Now the notation of the weak entity set, that is formalized above intuition. So entity set that has not sufficient attribute to form a primary key, that is known as the entity set. For example, ID has a supporting feature. ID has a sufficient attribute that is given to make as a primary key. So this is not a weak entity set. But the weak entity set is that the primary key which are not dependent or which are not formed as a or which do not carry any sufficient attributes to form a primary key, that is known as a weak entity set. An entity set that has a primary key, that is known as the strong entity set. So any attribute that has a primary key, that is a strong entity set. Any key that has not a primary key, that is known as a weak entity set. So one is a strong, one is a weak. So for a weak entity set to be meaningful, it must be associated with another entity set known as the identifying or owner entity set. Every weak entity set must be associated with the identifying entity, that is a weak entity set is said to be existent or existence and dependent on the identifying entity set. Right. So the identifying relationship is many to one from the weak entity set to the identifying entity set. In our example, the identifying entity set for section is course, and the relationship sec course, that is a section course, indicate the section entities with their corresponding course entities in the identifying relationship. The primary key of a weak entity set is formed by the primary key of the identifying entity set plus the weak entity set discriminator. Now this is the ER diagram with the weak entity set, that is a section course is a weak entity set, that is a variable, that is a sec underscore score, that is represented by the double diamond sign. Weak entity set is depicted by a rectangle in the ER diagram like a strong entity set, but there are two main differences. The discriminator of a weak entity is underlined with the dash, right, rather than the solid line. The relationship set connecting the weak entity set to the identifying strong entity set is depicted by the double diamond. This is a double diamond that is available. In figure 7.14, the weak entity set, that is a section, depends on the strong entity set via the sec course. So this is a course, this is a section, this is depending, or we can say this is related with the section course. A weak entity set can also participate in the relationship other than the identifying relationship. Now next is ER diagram for the university enterprise. So this is the ER diagram, that is a diagrammatical representation, that is how to represent the university in a ER diagram. So in figure 7.15 we show an ER diagram that corresponds to the university enterprise that we are using thus far in the text. This ER diagram is equivalent to the textual description of the university ER model, but with different or several additional constraints and the section not being a weak entity. In our university database, we may have a constraints that each instructor must have exactly one associated department. As a result, there is a double line in the figure 7.15 between the instructor and the instructor or institute or instructor department. There is a double line that is not associated with the we can say that is not associated with the exactly the one department. Further, there is an arrow from the instructor department to the department indicate that each instructor have at most one associated department. This is also the arrow that is denoted, that is a one-to-one relationship or one-to-many relationship. Similarly, the entity set course and the student have double line. So these are the double line, course and the student. Where is the course? This is the set course, that is a double line, right? Now let's see, this is the course department, this is the department, this is the student department, this is the instructor department. In the department there are three fields, there are three attributes, that is the department name, building and the budget. In the course department there are course that is related with the course. This is the course ID, title and the credit. This is the section course, this is the section, that is section ID, semester and the year. This is the time slot, that is the day, start time and the end time. This is the classroom, building, room number and the capacity. So these are the various fields that is associated with each other. And this is a one-to-many relationship. This is also one-to-many relationship, one-to-many. This is one-to-many. The relationship between the student and the instructor is the advisor. That is the instructor advise the student. Now teacher and the section then takes, there is a one-to-one relation, one many-to-many relationship among them. So this is the ER diagram for the university enterprise. Now next is a reduction to the relational schema, that is how to reduce to the reduction schema, that is what are the various schemes that is available for the reduction to the available schemas, that is the relational schemas. Now we can represent a database that conforms to the ER database schema. So we are dealing with how to represent the database with the ER database schema by a collection of relation schema, that is by a collection of various entities that is represented by a relation schemas. For each entity set and for each relationship set in the database design, there is a unique relation schema that is available to which we assign the name of the corresponding entity set or the relationship set. So we can represent the database that conforms to the ER model, ER database schema by a collection of the database or relation schemas. For each entity set that is available and for each relationship set in the database design, there's a unique relationship schema, relation schema that is used to assign the name of the corresponding entity set or the relationship set. Both the ER model and the relations or relational database model are abstract. So both the model that is used, that is either the ER model or either the relational model, that is the abstract model, logical representation of real world scenarios. Because the two models employ similar design principles, we can convert an ER design into the relational design. In this example, we describe how an ER schema can be represented by a relation schema and how constraints arising from ER model or from ER design can be mapped to constraint on the relation schema. So this is the main part, that is a relational schema, that is how to represent or how to reduce to the relational schema. So the first topic is the representation of the strong entity set with the simple attributes. What are the various simple attributes, or what are the various attributes that is a simple attribute that is associated with the strong entity sets? So let E be a strong entity set with only one simple descriptive attribute, that is the A1, A2, An. We represent this entity by a schema known as the E with the n distinct attributes. There are n distinct attributes that is available Each tuple in a relation on this schema corresponds to one entity of the entity set E. For the schema that is derived from the strong entity sets, the primary key of the entity set serves as the primary key. So this is the primary key. There is a student with three attributes: ID, name, total credit. Note that since student ID is the primary key of the entity set, it is also the primary key of the relation schema. This is the ID, that is the primary key of the relation schema. Continuing with our example, for the ER model, all the strong entity sets except the time slot have only the simple attributes. The schemas derived from these and strong entity sets are: what are the schema that is derived? There is a classroom, there is a building, room number, capacity, department, department name, building, budget, course, course ID, title, credit, instructor, ID, name, salary, ID, name, total credit. So as you see, both the instructor and the student schemas are different from the schema that we have discussed in the previous chapter. Now next is how to represent the strong entity set with the complex attributes. So if there are multiple complex attributes that is available, that is also represented with the help of the strong entity set. That is, the complex attributes is represented with the strong entity sets. So when a strong entity set has a non-simple attributes, things are a bit more complex. We handle composite attributes by creating a separate attribute for each of the component attributes. We do not create a separate attribute for the composite attribute itself. To illustrate, consider the version of the instructor entity set that is depicted in the figure 7.11. For the composite attribute name, the schema that is generated for instructor contains the attribute first name, middle name, last name. There is no separate attributes or schema for the name. Similarly, for the composite attribute address, the schema that is generated with the attributes street, city, state, zip code. Since street is also a composite attribute, that is also represented by, or that is also replaced by the street number, street name, and the apartment name. So this means we can use the complex attributes or divide the complex attributes into the various parts by using the strong entity sets. Then multivalued attributes are also treated differently from the other attributes, that is represented with the help of the ER diagram. So every phone number of an instructor is represented as a unique tuple in the relationship on the schema. Therefore, if we have instructor with the ID 22222, if there are 5 twos and the phone number 5551234, the relationship that is available has two tuples. Now, representation of weak entity set, that I'm not going to start right now. So let's finish the class over here only. So if there is any doubts, any suggestions, any advice, you can ask the doubts from me. So that's all for today's session, and we will be taking your next topic, or I'm taking your next topic in the next class. Your next assignment, sorry Joseph, the next assignment I will give you within 1 week only. All right? E-commerce. I'm giving you an assignment on the e-commerce. Yes, Joseph. Yes, Joseph, tell me. Yes, e-commerce. I'm giving an assignment on the e-commerce. E e-commerce. No, 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 no. I will give you in the coming week. That is in the next week. Okay. So thanks a lot. We will take next topic, that is how to represent the weak entity set in the next class. So that's all for today's session. Thank you so much everyone. Bye bye.